So here we have Lanzar 7K, which was the last amplifier that I was working on my previous live stream. And if anybody was watching, you'll know what the issue was with the voltage regulators. If you weren't watching my previous live stream, then we had issues with the 12 volt regulation circuit. Oh, excuse me. There are two voltage regulation circuits. There's two over here which are KA712s, and these take a 12 volt reference from the negative rail. These ones over here just take a 12 volt reference from ground. So you have two over here that create 12 volts above ground, and these two over here create 12 volts above negative rail. We had one KA712 over here getting red hot, like 150 degrees within a few seconds of turning the amplifier on. When the amplifier blew, when this amplifier went down in a bad way, it blew the output section, and it smoked up the FETs on this bank here, which is connected to this driver. When this happened, it probably took out, because this driver IC appears to be being fed the VCC 12 volts from this voltage regulator, and so this driver IC was dead, and it probably killed this driver IC also. Hello Elena, how's it going? So therefore, I didn't change that. I didn't notice that this was dead before. So what I did is I bought a new IR2113. I dropped it in there. I turned it on, and this was getting up to 150 degrees, and it seemed to have blown. So I reckon what happened is that this was shorted out, and so rather than giving 12 volt reference to this, it gave something much worse, and so it killed my new 2113 that I dropped in. So yeah, it seems that this being dead, well, it did something to our new 2113 that we put in, because the new 2113 that we put in is now dead. As luck would have it, I actually have two Lanzar 7K boards in the workshop to work on, and the second board that I've got, which I haven't started yet, seems to have less problems on the output section. So because all these chips, all these ICs are in headers, it's quite easy for me to chop and change bits from one amplifier to the other to you know, speed up the process in troubleshooting. So far, off camera this evening, I've been doing a little bit of work on here. Over here by the voltage regulators, there were two capacitors which are 25 volt, 100 microfarad. When we took the voltage regulators out of the circuit, it appeared that one of them had far too high voltage on leg 3 of the voltage regulator. So what I did today is I removed the two capacitors that were on the regulators. I measured them and they measured fine, but I replaced them anyway with some spares that I had. And when I replaced them, the issue seemed to go away. The voltage regulators seemed to then have the correct voltage on each of the pads. So I refitted the voltage regulators, and they work good. They don't get hot at all. Well, actually, that's a lie. One of them was getting hot. So this one was the one that was heating to over 150 degrees, which was dead. And this one wasn't heating up much at all. After I fitted the new capacitors and I fired it up without the drive chips in the board, I then noticed that this one was warming up just a little bit to maybe 30 degrees, and this one was staying cold. So I was like, okay, a little bit strange, but no, that might just be because this one's powering some other circuit that this one's not. So I was like, okay, fine, no worries. So then I left it on for about a minute or so, and I was having a look with my thermal imaging camera. I was checking out, seeing what was running hot and what wasn't and stuff. So I noticed that one of the ICs over here, the new one that I put in, was running super hot, and so I was like, oh crap. So I removed the IC that I replaced, and I went to my other Lanzar 7K, which is over here in the workshop. I installed one of the 2113s from that amplifier, and I dropped that in, and it no longer heated up. So all four of my 2113s are now running stone cold with the amplifier in operation. But the amplifier was still drawing a bit of current, and this one was still getting to about 35 degrees, and this might not be an issue, but I was like, I wonder if anything else is getting hot. So I was looking at this here. This is the main driver board. So this amplifier is actually fucking really old, really old style Class D. it's using a 4070 chip, so the 4070 IC here. I believe this is quite similar to the HIP 4080, I'm not sure, but I believe this is what is doing all the Class D stuff. So what I did is I powered the amplifier up, and I left it for about a minute, and then I removed this chip, and I laid it here, and I measured the heat. I was seeing how hot things were on this board, and the 4070 was actually running pretty hot, like up at 50 degrees, and I was like, I know that these chips can run a little bit warm, but I was like, it's you know, it's running a little bit warm there. So just to check things, I went and grabbed the other driver board from the other Lanzar 7K that I've got, which has the same chip. It's exactly the same driver board because they're the same amplifier, and I dropped that in. And when I put the driver board from the other amplifier in, it doesn't get hot. None of this stuff heats up. So obviously there's some difference. There's something possibly not quite right with the original driver board that was in this Lanzar. So if we take our two driver boards here, and I take my multimeter on diode setting, I found some anomalies here. So on the good driver board, the one that doesn't heat up, pin number 5, so if you probe between pin number 5 and 6, 7, 8, 9, 10, so between 5 and 10, I haven't checked up the data sheet to work out what pins do what just yet. We should have a reading of 626 on the multimeter in diode setting. On the one that was in the amplifier, we have a direct short. Oh no, sorry, we have 29 ohms. So we have 29 ohms there, and we have 626 on diode setting here. So obviously either the chip on here, the 4070 is dead, or something else on the chip. I have checked over these diodes and this small transistor, that seems fine. These Zener diodes seem fine. But there must be something else on this chip that's dead. So. And that's where we're going to go from now. So obviously I've got two of these amplifiers to repair. Having two of these amplifiers to repair makes life a lot easier because you can chop and change things between boards. It's quite unusual that two amplifiers die in exactly the same way. So we've probably got two amplifiers with two slightly different issues here that I can compare. I can compare between. First things first then, because I want to get these driver boards the same, we've obviously got one driver board that's got an issue. So on the driver board that has the hot 4070, I'm going to remove the 4070 chip, and I'm going to see whether there is still 29 ohms between pin 5 and 9, what was it, 10? 5, 6, 7, 8, 9, 10, yeah, between 5 and 10. I'm going to remove the chip and see whether there is still that low resistance between those pins. So that's what we're going to do first. So I just have to push the legs away from the edges of their old holes. So now that we've removed the chip, let's just measure and see whether we still have the 29 ohms across 5 and 10, was it? Ah! Okay, so we don't have the low resistance where we did. Wait, there it is. There it is. Okay. So, pin number 1, 2, 3, 4, 5, 6, 7. Okay, between pin 7 and pin 8, 9, 10, 11. Okay, so between pin 7 and 10, 11 there is 30 ohms and 29 ohms on the chip itself. Okay. And that is not present on the one that works. Okay, phew. So yes, we have a dead chip there. So now in this amplifier we have new driver IC, new driver board with Class D chip, new voltage regulators. So I think everything is ready. The only one question that I have on this board now is usually when we have the amplifier ready to go and I think everything is going to work okay, usually you can see these square waves on the low side drive only without the FETs, only if you put some signal in the RCAs, so like 45 Hertz or 50 Hertz or something, put some signal in the RCAs and then you can read the square waves on the scope here at 45 Hertz. But in this amplifier, there's nothing. There's no square waves, nothing at all with the FETs out. So I think maybe that's just a design with this amplifier. So I'm gonna try and put some FETs in the board and see whether it comes to life. I'm gonna take my thermal imager here, so I'm ready to spot anything that gets super duper hot. I'm confirming we have all the correct voltages on the high side and low side. So low side, yes. High side, yes. Low side, yes. High side, yes. And low side, that's a high side. And that's going to be a low side. And that's a high side. And that's going to be a low side. Okay, cool. So there's no DC where there shouldn't be. Let's see if anything is getting hot just whilst we're pulsing these voltages here. Okay, so time to check for Class D switching. Do we have any Class D switching? I'm going to turn my scope down a bit so we can actually see the wave nicely. This is the part where she could explode. So the amplifier is pulling 2 amps and there's no Class D switching to be seen anywhere. Nothing's getting hot, everything's staying nice and cold, all the FETs are staying cold, everything's good. And also, interestingly, there's no green light either on the amplifier. So that's potentially something to do with some small voltage regulator circuit. So the red protect light does light up, but then the light doesn't turn green. It just says nothing. So that goes to show that there should indeed be some switching waves on the low side drive when the FETs are out the board. So the purpose of that test was to see whether there should be Class D switching waves on the low side drive, whether it needed the FETs in to even do that. So the answer to that is no, I don't think it does need the FETs in to do that. It's just that we have some other issues. So let's just check we have all of the correct, all of the desired voltages. Actually, I can do that. I'm going to take the FETs out just for safety, because if something goes wrong and we slip our probe, we can explode a FET. So I'm going to wait for the voltage to sink down to safe levels. We need to ensure that these driver ICs are turning on. So what I'm going to do is I'm going to actually go ahead and have a look at I'm going to have a look at the data sheet for this. We have a logic supply, which is going to be where the waves are. Where we got so a logic input for high side gate driver output. So there should be some small square waves here. There should be some logic for input gate. That should be some small square waves there. Logic supply should be some DC, I think. Logic ground should be nothing, or should be referenced to negative rail. High side floating supply should be 0. Low side floating supply should be negative rail. The gate output for high side should be 0. Low side gate drive output should be negative rail. Low side return should possibly also be negative rail. Okay. FETs are removed, and we're also going to remove all 4 of our driver ICs. So it's possible that the op amps on the preamplifier section are not getting their VCC, because I imagine it's probably the same regulated voltage that powers this VCC for these op amps as the powers the green LED. So VCC on these op amps should be 5 volts plus minus. So we need 5 volts on the minus, and okay. Interesting. There's no plus 5, so that's probably why our green LED is not working. We don't seem to have positive 5 volts VCC for these op amps. So I imagine that these voltage regulators here are going to be responsible for that. So we have negative 18 volts on this one, and then a negative 11 point something. On this one we have positive 20 volts, and then okay, so this voltage regulator, KA78T12, maybe is not working properly because it's not giving us 12 volts, it's giving us 6 volts. Yep, so I seem to have a spare 7812 on this bullshit US amps. Let's see whether that has fixed it and given us proper 12 volts where we should have proper 12 volts. I really hope it does. I really hope it does. 2.4 amps. Aha! 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 We now have a green light on the amplifier. And we have plus 11.5 volts on the VCC. So that's a very good. So I'm now going to go ahead and guess that this is fine. I'm going to load up the driver board and the driver ICs and everything else and see if we get the drive waves on the FETs, and we probably are, and it's probably going to be beautiful from here on out. And we're giving it about 44 hertz at the moment, and 3.6 volts peak to peak of output voltage. Okay, so now we have some signal going in here. Let's power it back up and see. ¡Ajá! ¡Muy bien! ¡Está aquí! Yes! So, low side drive waves, it just needed some RCA signal to oscillate. Okay, fantastical. So let's see, we have good low side drive on this bank. And then this bank over here. Yes. Yes. And then this bank over here. Yes. Yes. And finally, this bank over here. Yes. So that's good. That's fucking good. So now, that looks nice. I'm pretty confident that we can fit the new output FETs and it'll work well. We have nice looking drive on all the low sides here. Very good. A pair of DA. Okay. So we put one FET per bank, so we have one. So we have, what's that? It's, is that a low? I think that might be high. So high, low, low, high. High, low, low, high. Okay. And last check with the multimeter before we apply 100 volts. So 521 or 584 in perhaps 584. That one's a 512. It's a bit different. 577 and 512. Oh wow. Okay, there's something not correct on this side. That's not right. So it's a good job I checked this. So gate resistors along here should all be, what's it, 5 ohms? Yeah. Okay, so we should have 72 ohms. So I'm checking one of these ones that reads good. So we should have 72 ohms between the gate and what's that pin? 1, 2, 3, 4, 5, 6, 7. So we should have 72 ohms between the gate and pin 7. So on this one, the gate and the pin 7, we have is 72 ohms. Okay. So maybe it's on the source then. So on this transistor, the reason I'm now stopping briefly and questioning one last thing is because a quick check you can do before you apply final power to the amplifier when the FETs are in is you can put your multimeter probes, you put the positive on the source and the negative on the gate, and you should see a number somewhere between 300 and 600 or something is generally the numbers that you see. Depending on the drive, you're basically measuring something on the driver circuit. So all these are all reading between 520 and 570, which seems to be the correct thing for this board. See? Like this. But then this very last one here, which is in the bank that died originally, is measuring some crazy 14, so that's not good. So I've already checked continuity between the gate and the driver, which is 72 ohms, which is here. So the gate is connected to the driver IC. That's not the problem. The problem appears to be maybe that the source isn't connected. So the sources are connected together here, which is correct. The sources are also connected in parallel to these two. So that's also correct. And they are also connected to this side, yes. And this side, so the source is connected there. So, okay, let's see, what should the source be connected to on the driver IC? Let's have a look. So there should be a complete continuity to pin number 1, 2, 3, 4, 5. Pin 5, we should have continuity between the source and the driver IC. So let's see if that's the same on this side. Source and driver IC, 1, 2, 3, 4, 5. Okay, no, there is not continuity between the source and pin 5 on the driver IC. So there's probably some kind of fusible resistor here which has broken. So let's see, on the good side, what is the source connected to? Is probably connected to like a large resistor. Aha, see here? We've got a, what is this, large resistor here. We've got 22 ohms we're connected to here. And on the underside of the board, yeah, so it goes through this large resistor. So let's just make sure that that is actually correct and working here. Aha, so possibly this large resistor here is actually blown. Yeah, I think this acts as kind of a fusible resistor or some current limiting resistor for the source pin of this FET. And that doesn't seem to be connected, so let's pull the amplifier board off of the rest of the thing. This resistor should be 22 ohms here. Holy crap, this amplifier went down in a bad way. Okay. So yeah, the resistor is 22 ohms. Perhaps then, maybe it's a trace. Maybe the trace to this resistor is fucked because we don't have the continuity between the actual source leg. What else are we connected to here? So the source, I'm just going over on the good side. I'm just making a mental note of what the source is connected to, where everything is connected to. So it's connected to one of these diodes here. So let's just check there. So there's a small trace that comes off of the source trace here and goes around here and somewhere in here. Okay, small resistor here is connected to. So this small resistor is a brown, black, gold. So let's see. That measures some crazy high number. I think that should be low. Yes. Yes, sir, we have found the culprit. So there's a dead resistor. So this what is it? Orange, black, gold. Can somebody remind me what the fuck that resistance is? I can't remember the bands off the top of my head. It's a 1 ohm. Yeah. Ones and zeros. Black and brown. I don't know if I have any 1 ohm resistors, so I'll have to have a look in my drawers. So yeah, it's the resistor that's opened is this small one here, R303. That's between the source and pin 5 of the IC. Don't you have another one still in repair? Why can't you take it off? Holy shit! Yeah, I do. I completely forgot about that. The Master Chief. Thank you very much for reminding me. All right, let's go and get the other Lanzar board. Ah, holy fuck! No, it's not. This one's dead as well. So they're obviously a common part to die in these amplifiers. Let's find one that works first on the board. So all the other 3 of them read 1 ohm, apart from the one I decided to pull. Oh man, that's some bullshit right there. Components, places like that. Okay, so now we've replaced that resistor, we should we should now have the same diode meter reading values across all of this. And it's maybe a good idea just for me to quickly check some of the other resistors in that location, because this area obviously got hit quite badly by whatever killed the amp. Okay, so yeah, awesome stuff. We now have the correct diode mode reading on this area, 569, so that's good. So replacing that resistor has sorted out that anomaly. Yep, most of the other resistors there look fine. Cool, so I think now we're safe to power her up. Finally. It might need a load on the output section to start oscillating, to start switching the Class D. Okay, yeah, so no square waves. Okay, so I'm gonna, so the thing that made the square waves appear before was plugging some RCAs in. So I'm just gonna plug some RCAs in. Ah, there we go. So there we had the switch wave, and I just let it oscillate for about half a second then, because half a second is enough to heat these FETs up if there is a problem. So I'm just gonna go around and check the FETs are still dead stone cold. Okay. Also 23 degrees, okay, they're just a bit hotter than the floor, that's why I have the difference there. So let's do that again. This time I'm going to leave the amplifier turned on. Once the amplifier comes on and starts to switch, I'm going to remove the RCAs, and the switching should stay on the FETs. Because these amplifiers, they either often need a load on the outputs for the feedback circuit to work properly, or they need some RCA signal to kick-start it into working. Let's turn her on again. Wait for that Class D switch to come. There it is. Remove the RCAs and it stays on. Great success. Okay, fantastic. Just going to quickly go ahead and check for heat. Everything's staying cold, although this FET... Holy shit. Okay, so this FET over here that had the blown resistor is reaching 40 degrees, pretty hot. Whereas all the others are staying stone cold. So there's still some issues with this amplifier over with this batch here that blew before. There's something that's not right still here in this area. This FET gets pretty hot. What I want to do now is, I'm wondering why that's getting hot. So I want to check the low side drive. So I can see that I can quite clearly run the amplifier just for a brief moment. I can run it for like a few seconds and it doesn't get too hot. So I'm going to turn her back on, and I'm just going to check to see what does the low side drive, what should it look like. So to check the low side drive, we need to turn our scope. We need to switch it to AC coupling so that we get rid of the DC on that, and then zoom into 2 volts divide, and that should be good. We should be able to see the low side drive nice and clean there. So I'm going to power her up again. And we're going to pause the scope on the low side drive. Wow, okay, so there's quite a dip there. That could be normal. So we're going to go ahead and compare all the rest of the low side drives. So the amplifier was only on for a split second then. So yeah, that's what the low side drive looks like on a batch that doesn't heat up. Good, fine, no problems. So let's go and compare it to another batch. Okay, so again, the similar shape. I didn't remove the RCA this time, so that's why I've got a thick patch in the middle where it was making audio. Does the shape look the same on this one? This is the bad set. This is the bad set. Okay, so there's something different about that one, isn't there? There's something different about that one that's not there with the others. So I'm gonna store this waveform actually. If I zoom in a tiny bit more, I'm going to store the waveform. Okay, so you can see there that the drive wave has a big ass spike on the way up, and that's the low side drive, and that is different to all the others. So I'm going to go ahead and on my scope, I'm actually going to store that trace so that I can remember what it looks like. And now I'm just going to probe a good drive wave, just to get a reference of what a good one should look like. Okay, now the other ones look beautiful. Okay, so this is our reference. This is what our drive wave should look like. Recall setup 1. This is what our trace did look like. This is what we're aiming for, and so it's a different amplitude. It's lower in amplitude as well by the looks of things. There's some something that's not in sync or something that's going on there. Got a big spike. So the FET's kind of being told to turn on, and then what it looks like here is it looks like the FET goes to turn on, and then when it reaches the on threshold, it's then pulled down and then goes up again, or something like that. That's what it looks like to me. Those waves are supposed to be square. They're supposed to be square-ish. They'll never be completely square because I've got a quite fast oscillation frequency, and the gates of these FETs have capacitance. So yeah, it'll never be completely square, but there should be a nice rise up and then a sharp off. So the high side should look like that. Okay, nice big, pretty even square. So that's on the gate of the high side. So on this side over here, aha! So the high side, I'm gonna do the same thing on this one. So the high side then is actually not turning on very fast, and that's as a result of the low side. So the low side drive had this kind of spike first and then a ramp, and so the turn on time was very slow. Whereas so that then equates to a slow turn on for the high side as well. So the good wave should be sharp up with a small step, and then slower down. It's more slopey on the way down. The bad one is sharper on the way down but more slopey on the way up. It's almost like there's a backwards diode somewhere. Look, slopey down, sharp up, slopey up, sharp down. Bad, good, bad. It's like they're mirror images of each other. Good. There we go. These are the two drive waves together. So this is the high side that's taking too long to turn on, and this is the low side that's got a spike on the way up. Ignore this bit of noise at the top here. That's not meant to be there. That's not relevant at this point. So after we got that far with the Lanzar, there was another 4 or 5 hours worth of live stream, not just on that evening but also the next day, and then a couple of days after that as well. So we didn't get past that point for a long time. That issue with the low side drive having the spike on it and the high side drive having a slopey start, that issue remained for hours and hours of troubleshooting and changing things and swapping things out. We tried changing the FETs, we tried changing for a different type of FET, 24N40F as opposed to 38N30. I tried replacing the bootstrap circuit, I tried replacing the snubber circuit, I tried different drive ICs, I tried changing resistors, I did so much work, and I have lost so many hours of my life to this stank-ass Lanzar. And I won't show you all of that because all the rest of the footage from the live streams is just me systematically changing things, going, what the fuck's wrong with this? Changing some other things, pulling some things off there, changing, swapping, getting absolutely wound up that I could not sort this issue with the low side drive and the spike on there, and this FET was heating up. We had H1 Nicholas on the live chat and a bunch of other guys, Ermachoos on the live chat, suggesting things for me to change, and I was doing that and I was changing other things. Yeah, there was some really good knowledge on that live stream, but it's like another 5 or 6 hours worth of footage, and I can't be bothered to edit through it. It's taking me far too long. So rather than showing you systematically changing things that don't actually lead to any progression, I'm just going to skip ahead to show you how and where I found the issue, because I did resolve the issue in the end. It just took a long time to get there, so I'm going to skip ahead, and I actually found the issue. I stopped bothering to live stream my attempts at this repair because it was just taking so long, and I thought, you know what, screw it, let's just replace loads of resistors and diodes, just blindly replace them in that area that was faulty and see if it works. So I had a good Lanzar that I swapped out all the parts from, so I took a good one and the bad one, and I swapped all the resistors and diodes from the good one to the bad one to see if that fixed it, and this is what happened. It works, yes! I actually don't know what the issue was. It could be a number of things, because I did like a lot of things at the same time, and and one of the things I did obviously fixed it. Oh yeah, look at that fucking beautiful wave, and look at this flipping beautiful high side drive. Oh yeah. I will go through everything that I changed, right? So in a last resort kind of blind attempt, at making this thing work. Okay, what I did, this is the batch that was giving me issues. Okay, so in a last blind attempt to try and work out what was wrong, because I was looking at my low side drive. Okay, I was looking at my low side drive, and I probed my low side drive at the driver, and it kind of actually looked okay. You know that, do you remember the low side drive had that great big spike at the start of it, right? Well, I probed it at the driver's side, and it kind of looked okay. So then I probed it on the input side of the gate resistor, and it kind of looked fine, but it looked terrible on the other side of the gate resistor. But the gate resistor measured perfectly. It measured 63 ohms or whatever. It measured perfectly. Didn't measure out of tolerance or anything. So I not once did think that that was the issue. Okay, so it might have been the gate resistor. So what I did is I changed, right? So for both the high side and the low side, I changed gate resistor, pull down diode, pull down resistor, gate resistor, pull down diode, pull down resistor, and the snubber network for this as well. So I changed capacitor, resistor, diode, resistor, 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 diode. So that is a whole handful of things. So this is all these are all the things that I changed. I pulled off the board. The bad component is somewhere in this pile. Obviously, I stole those from the good board. So what I have to do now is I could either fit these in one by one and see if the issue presents itself on the good board. So many hours. How much shall I charge this guy? There was a lot wrong with this amp. I think the issue was the clear diode. Okay, so shall we test all those parts then that I removed? Okay, let's test all the parts I removed, and I bet you that they're gonna probably read fine. Let's start with the capacitor. The blue snubber circuit capacitor is fine. So the snubber resistor reads 22.2 ohms, which is correct, I think. Okay, so this resistor, this diode reads this. So 711. And what does the other diode read? I wonder if it's this one. So who guessed it was the clear diode? You might be right, my friend. Holy shit! Who guessed it was the clear diode? Okay, holy shit, yes! The glass diode! Ha ha ha! Who guessed the glass diode? Small glass diode. And the small glass diode, this is responsible for, I think on this one it's responsible for pulling the wave down, which doesn't make any sense for what we were seeing. We were seeing the wave going up slowly. It doesn't make any sense at all. But cool. So let's put this thing away. And so I need to order FETs for this anyway. So yeah, this is repaired. Fine. This is all good to go. Fully repaired. Ski app bop bomb. So I need to order some FETs for her anyway before she goes back in the case. So I'm going to put this all down to one side, and I'm going to lock off the live stream just now, but I will start it up again in about 15 minutes time, and we'll look at the clipping detector.